My name is Peixu. I'm going to briefly talk about our ECCV paper. This is a joint work between Clemson University, CMAT, and Roblox. In this work, we propose SocialVAE, a normal approach for human trajectory prediction based on a short-term observation. SocialVAE uses an architecture of Timewise VAE combined with a conditional prior and a backward approximated posterior to provide multimodal predictions. We further introduce a social attention mechanism encoding the observations of an agent under prediction. We also propose an optional post-processing technique to improve the prediction diversity of vanilla SocialVAE. We experimentally show that SocialVAE achieves state-of-the-art performance on ETH UCY and SDD benchmarks, and more complex scenes involving NBA players' interactions. The basic architecture of SocialVAE is a variational autoencoder. However, instead of using a certain latent vector for prediction at all time steps, we introduce time-wisely generated latents for the sake of better capturing the highly dynamic nature of human decision-making during navigation. The final output of SocialVAE is a distribution of trajectories represented as a series of displacement. To capture the movement pattern of the agent under prediction, we develop an attention mechanism to encode the observation. Our approach only relies on the observable social features and states that are exhibited by neighbors. It therefore can work with an arbitrary number of neighbors and allows to support neighbors that are not consistently tracked during observation. SocialVAE takes the result of observation encoding to generate latents conditionally. This results in a conditional timewise VAE architecture as the backbone of SocialVAE. Beyond that, SocialVAE performs the posterior approximation backward. Such a structure makes the encoder always to take into account the whole trajectory, including both the future and historical segments when performing encoding at each time step. Based on this architecture, we further propose the final position clustering (FPC) as an optional post-processing technique that relies on k-means to improve the diversity when a small number of predictions are needed. During training, SocialVAE is optimized to minimize the evidence lower bound time wisely. In our implementation, we use Gaussian distributions to model both the prior and the posterior and the distribution of position displacement at each time step. This results in a loss function consisting of the reconstruction error and a sample-based KL divergence, where the latents are drawn from the posterior. When performing prediction, we draw latents from the prior only. The ground truth future trajectory for posterior approximation are not required anymore. Here we show some prediction results from UCY benchmark where we visualize the predicted trajectories and the corresponding heat maps in the first and second columns respectively. Besides the multimodal prediction, SocialVAE can also provide attention maps to help interpret the predictions, which are shown in the third column. Overall, in both benchmarks, SocialVAE achieves state-of-the-art performance with an improvement around 10% and more than 50% in certain test cases compared to current exciting approaches. As more challenging tasks, we extract two subsets from the SportVU NBA movement dataset, which focus on the scenes of players grabbing the rebound and scoring a basket respectively. This data contains a rich set of human-human interactions and lots of non-linear motions. Here, for example, the player under observation makes a quick maneuver to lose his defender. As it can be seen, our attention module can effectively identify the teammates and opponents, understand the importance of the location of the ball, and facilitate high-quality predictions. Despite such complex interactions in these datasets, SocialVAE provides high-quality predictions with distributions covering the ground truth trajectories closely. Overall, our approach combined with our clustering scheme significantly outperforms the exciting methods on the two datasets. In summary, we propose SocialVAE as a novel approach for multimodal human trajectory prediction. We show that SocialVAE achieves better performance on multiple benchmarks over exciting trajectory prediction models. We refer to our paper and project webpage for more technical details and results of SocialVAE. Thank you.